Now let's discuss how the variation of ionic radii of this isoelectronic series that contain neon magnesium 2 plus F minus Na plus O2 minus. As we discuss about this isoelectronic series, now for example, so we said neon has this electronic configuration 1s2, 2s2, 2s2, 2p6. So neon has this configuration 1s2, 2s2, 2p6. Whereas this magnesium, so the magnesium atom has this electronic configuration 1s2, 2s2, 2p6, 3s2, because the atomic number is 12. Here the atomic number is 10. But when it comes for magnesium 2 plus, you get Mg2 plus. So 2 electrons are missing. So 1s2, 2s2, 2p6. So you don't have these 2 electrons any longer when it comes for magnesium 2 plus ion. Similarly, we can go ahead with the rest of the elements. So the elements which are given to us, fluoride. Now let's consider fluoride ion. First let's consider the fluorine, which is 1s2. So it has the atomic number 9. So 1s2, 2s2, 2p5. But then the fluoride ion, so there is one excess electron. So therefore 1s2, 2s2, 2p5. So because of the addition of one electron, 2p6. Because of the addition of one electron. And we'll consider the other one, sodium plus. So before we go to sodium plus, sodium is neutral atom 1s2, 2s2, 2p6, 3s1, because the atomic number is 11. When it comes for sodium plus ion, it is 1s2, 2s2, 2p6, because this electron has been removed when the positive ion is being formed. Lastly, the last ion given in the list, that's O2 minus. So let's consider O2 minus. So before we consider O2 minus, actually we can consider the neutral oxygen atom. So the electronic configuration of the neutral oxygen atom is 1s2, 2s2, 2p4. When it comes for oxide ion or O2 minus, there are 2 extra electrons present. So 1s2, 2s2, 2p6, because to this 4 extra 2 electrons are added. So and now we can make a comparison. So as you can see, this neon, magnesium 2 plus, fluoride, sodium plus, and these oxides. All these ions and the neon atom all are having the same electronic configuration. So that's the reason why we call these as isoelectronic. We call them as isoelectronic ions, and neon, it's an atom. And now we are supposed to predict the variation of the ionic radii of this neon, magnesium, fluoride, Na plus, and oxide. So how can we do this? So we can go ahead with that. Now, as you can see, the number of electrons remain the same in all of these ions and the neon atom. So therefore, the number of electrons is not a factor that we can make a comparison. So we have to consider the charge and whether it's neutral or it's charged, or whether it's a cation or anion. So you all should know, when the positive charge is high, the electron cloud is dragged more towards the nucleus. So which means we can conclude that magnesium 2 plus should have the lowest ionic radius, and the next in the line should be Na plus, because the nuclear charge is less. Next, you can consider the neutral element, which is neon, and then fluoride ion, and lastly it should be O2. Now, why are we saying that the anion here, the more than the fluoride ion, oxide ion is having a larger radius? Usually across the period we used to say oxygen and fluorine used to have the lowest or the smallest radius, but and here also, the compared to fluoride, oxide, it has more electrons, more inter-electronic repulsion, so this is going to be the odd.